Oh, I should be recording, but let me explain here. If we have x plus 5 over 8, and then I have 2x minus 7 over 8, how can I put those two together? Well, if I have common denominator, I can put them together. Are you all with me? And I get x plus 5 plus 2x minus 7 over 8. That's an algebra rule. So if you have common denominators, you can put everything together on top. What we are going to work towards is we have a denominator, and we are going to break up into two separate fractions. Okay, so what's that going to involve? That's going to involve getting least common denominators. Okay, so what we're going to do is we're going to break up this single fraction into smaller fractions. So let's see how we do this. I'm going to put a little blurb here. I'm going to do it right here. So what I'm going to do is I'm going to rewrite 5x minus 3 over x plus 1 times x minus 3 as two smaller things that come together. Namely, it's going to be x plus 1 is one factor, and x minus 3 is going to be my second factor. I'm going to take my two factors and separate them. Now, to add them up, I have to have a common denominator. So I'm going to have to change both of them. But that leaves the top blank, because I can't just take 5x and slap it on the first one, and minus 3 and slap it on the second one. Why not? I can't just put 5x here and minus 3 here. Why not? Yeah, why, Dallas?
It's not a product on the top.
Because it's, okay, there's not a product on the top, absolutely. And number two, I need to have a common denominator in order to add up fractions. If I put 5x here, well, it's going to change when I get my common denominator. I don't know if I'm making any sense to anybody or not, but we want to break this up, and so the process is this. We put a temporary placeholder, okay? Capital A, capital B, capital C, capital D. It's a placeholder to say what would have to go on top of this to get us this over here. And then what we do, generally speaking, is we then say, okay, now using this placeholder, let's get this and make this into a single fraction with a common denominator. So we're going to multiply this guy by x plus 3, and then this guy's going to get multiplied by, oh no, I did that wrong, right? This guy's going to get multiplied by x minus 3, and this guy's going to get multiplied by x plus 1. Are you guys with me? Okay, so the first guy, a over x plus 1, is going to get multiplied by x minus 3 because I want to get a common denominator so that I can add these up. So I'm going to multiply this by x minus 3, top and bottom. And the next guy, well, he already has an x minus 3 factor, but again, we're working towards putting these together. And so he's going to multiply, and he's going to multiply by x plus 1, top and bottom. So now I have common denominators, x plus 1, x minus 3, and now I can put two fractions together when it has a common denominator. And so what that gives us is that's going to give us on top. Oh, and I like to distribute. Do you guys like to distribute at this point? Do you want to distribute at this point? Let's multiply this through so that we don't forget that we're multiplying through here. This gets multiplied through, and this guy's going to get multiplied through. All right, so on top, on the left, we have ax minus 3a. Make sense so far? It's fun. It's algebra. I love today because it's all about algebra. A lot less calculus and trigonometry, a lot more algebra today. And the second guy is bx plus b. And what's my common denominator that's adding everything up in the numerator? It's just your two factors, right? X plus 1, x minus 3. Okay. How's everybody looking so far? Does that make sense? You're going to have one to practice. But does that make sense? Does everybody see? So now the idea is I want to make this look like this. Well, that's got 4 things, and that's got 2 things, right? Well, we're still going to do some magic here. How do we make that guy look like this guy? Did anybody learn this method, how they learned this way? Have you guys learned this? How are we going to make the right side look like the left side? Does it make sense so far? Everybody's got it so far? How are we going to make this side look like this side? Well, I would probably put my like terms together. So do you see we have an AX and a BX? Let's put the X terms together, okay? So let's put the X terms together. And when I put them together, they're going to be right next to each other, right? So I'm going to put AX plus BX. And I'm going to set it right next to each other. And then I want the other terms that don't have X's and put them next to each other, okay? So I'm going to put minus 3A plus B. And now I'm going to use my brain a little bit. I've got 2 X terms, right? Those X terms have to equate to that X term. And these non-X terms have to equate to the non-X term. So if I have AX plus BX, are you guys okay if I do this? AX plus BX is actually just A plus B times X. Are you okay if I factor out the X? Like, do you see how there's an X here and an X here? Are you okay if I kind of factor that out? We're going to factor that out to the side. Why am I going to do that? I'm going to factor that out. This is what my brain says. Let's take that X and pull it out. And if I do, right, just pull it out. Justin, what am I left with? Do you see?
Just
A plus B, right? Just A plus B. Okay, good. And then I'm going to do this. People don't like to do this very often, but this is what my brain says. Anyways, this is what my brain says. So I'm going to show you what my brain says. Not that your brain has to say the same thing, but my brain says this. This number here, A plus B in front of X, is the coefficient. Let me write that down. It's my coefficient, right? It's my coefficient on X. And up here, what's my coefficient on X? It's 5. And then the second part, the minus 3A plus B, well, that guy's my constant. Do you see how he's just a constant term? He's just the term that doesn't have any X's. And that's my constant term right there, minus 3. And so what I do now is I set up 2 systems of equations that relate those 2 facts together. A plus B, which is my coefficient on X, has to equal what number? 5. You guys see that, right? And then the other thing, negative 3A plus B, has to equal my other number, which is negative 3, right? And what that does is that creates for us a system of 2 equations with 2 unknowns. And anytime you have a system with 2 unknowns and 2 equations, you can solve it. What if I said go solve it? Would you guys be able to go solve it? You can say, no, I don't remember this algebra at all. Would you guys know what to do? There's different methods. Different people use different things. Some people use something called substitution, meaning they'll take the first equation and solve for A and substitute it into the second one. Some people use something called addition-elimination method, where you have the top equation and the bottom equation, and you multiply by a coefficient or a number and then add down and cancel things. Do you guys remember those methods? Maybe? Addition-elimination method. I tend to prefer the second one. Well, it just depends on the thing. I kind of like the second method on this one because I notice I have a B in the first one and a B in the second one. And so I think to myself, well, if I multiply the second equation by negative, 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 and then add it straight down, it gets rid of my b's. That's what my head says, but everybody can do it a little different. Let me see what happens. So if I multiply my second equation by a -1, what that does is it gets rid of that positive b and turns it into a negative b. So I would kind of look at it like this. 3a minus b equals 3. And then if I combined those two equations by adding vertically, and I'm just going to put a little note here in case you want to Google it later on and look up like a Khan Academy video or whatever. This guy's called the elimination method, the addition elimination method for systems. So systems, this is called a system of equations. So if you forget this stuff, you can always look it up later. But this is a system of equations. This is the elimination method. I think most of us have done this before. It's just been a while, possibly. But if I add straight down, notice my positive b and my negative b goes away. And we're just left with 4a equals 8. And when I divide both sides, a is 2. And then I go back and I substitute to get my second value. So I know that a plus b is 5 from my first equation up here. So since a is 2, that means 2 plus b is 5, and so that means b is 3. Does this look familiar? Everybody's real quiet. Does this look familiar? The cool part about partial fraction integration is that the hardest part of this method is the algebra. Once you get the algebra, the actual integration piece is really simple. I'll show you why. All right, so what does this do for us? Okay, I'm going to give you one and I'm going to walk around. What does this do for us, though? This tells us A and B. So that means... ta-da, what do we have going on? That means that 5x minus 3 over x plus 1 times x minus 3 is equal to 2 over x plus 1 plus 3 over x plus 3. And you can check it by cross-multiplying and getting everything together. But what is that? Why did we do that? What does that do? Let's look at the bigger picture. Slow down. Who has a question? Did I lose you? Dallas, did I lose you?
What happened to the X?
Good question.
Or am I just really...
No, you're not. Yes, you're probably confused because I'm confusing. What I did was I took...
Oh, wait, I got it.
You see, I went back up here to the beginning, and I replaced the 2 where the 2 should be, and I replaced the 3 where the B should be. Yeah, Braden.
I got 4 and 1 for my B and A.
Ooh.
I did it like,
What did you do?
I solved for A and
So after I separate and pull out my coefficients, so I've rewritten my original integral, separated them out because we can integrate two parts separately with addition. This is just natural logarithms. Do you guys see this is natural logarithms? Either you see it, or you say to yourself, okay, I can let u, we'll just do it to the first one, let u equal x plus 1, du is dx, and so that means my first integral I could think of as 2 times the integral of 1 over u du, and we all know that 1 over u du is just the natural log of the absolute value of u. And so it's the natural logarithm. And so we could do the same pattern and not even have to do a u sub on the second one. What's the second one going to be? It's just going to be 3 times the natural log of the absolute value of x minus 3. And so our answer is actually going to be 2 times the natural log of x plus 1 plus 3 times the natural log of x minus 3 plus c. If you like to go directly, you can. If you don't want to go directly, you can choose a new u on that second one, right? So if you want, you can always choose a new u, x minus 3, du is dx, and you can always add in that second integral just to be safe, to make sure you understand what's going on. Okay, do you see what I'm saying there? If you don't see that natural logarithm pop out at you right away. All right? Let's see, so we could write this as x plus 16 over 2x minus 1 times x plus 5, and that equals a over 2x minus 1 plus b over x plus 5. And so if I put them together, that would be a times x plus 5 and b times 2x minus 1. And when I go to multiply that out, that's ax plus 5a plus 2bx minus b. And that's giving me a plus 2bx and 5a minus b. And so if you're doing it this method and not something different, you would set up a system. I'm getting a system of two equations, and my system is going to be, let's see, I have a plus 2b is the coefficient on x, which is 1, and 5a minus b equals 16. So if you're going to set up a system of equations, your equations should at least match mine, okay? And again, I just said the second guy is linear. The second one has a linear factor x plus 5, but the coefficient is just 1. And if that's the case, it's just a straight up natural logarithm, right? We don't have to worry about anything funky, but what I do need to do is worry about the fact there's a negative 1 on top. So when I take the antiderivative of 1 over x plus 5, that's a straight up u substitution, but because there's a 1 in front, I don't necessarily have to do the u substitution. It's basically that rule, that kind of cosine of 2x, you have to take and flip the 2 in front, right? Tangent of 3x, you have to flip. When you do an antiderivative, you have to flip that linear coefficient piece. So if you have a 2 as part of your factor, when you do your u sub, it comes out with a 1/2 in front. See if your answer is matching my answer. You should get, make sure I did it right, 3/2 times the natural log of the absolute value of 2x minus 1 minus the natural log of x plus 5. Is that what you guys got? How are we feeling? Yes, Olivia.
Do you have to put the minus 1, or can you just have just a minus?
You can just have a minus there. You don't have to have the minus 1. It's the same thing. Yep. In fact, it probably looks nicer without it. Any questions? How you feeling on partial fractions? You're like, okay, Tina, this is the first thing I understood in the past 2 weeks. No, I'm just teasing. How we doing on partial fractions, okay? I'm going to ramp it up one level, though, okay? I'm going to make it just a hair more complicated. So any questions? Everybody's okay so far? So, same thing. What do we got going on here? Notice we've got a polynomial on top of a polynomial. I've prefactored it for you, okay? On top, we have 3x squared plus 3x plus 96. On the bottom, I have x times x squared plus 6. Polynomial on top of polynomial. Think partial fractions, okay? Polynomial on top of polynomial. Think partial fractions. 3x squared plus 3x plus 96 on top. X times x squared plus 16 on the bottom. So we're going to break it up into two fractions on the bottom. So let's set ourselves up here. So we've got a fraction with x on the denominator. So we've got a denominator of x. And then I've got x squared plus 16. Now, I say special case non-linear factor. Non-linear means the power on the x is no longer 1, right? Non-linear means the power is no longer 1. Lines are ax plus b, right? Lines have a power 1. Non-linear means I have to have a higher power. Do you guys see I have a higher power on that factor? It's x squared. That's the only thing that makes this problem any different. But it does make it different. So, on top of the x, we're just going to put our normal a. But on top of x squared plus 16, now let's think this through. On top of x, we simply put a constant. So on top of x squared, I'm going to have to put 1 degree down. So I'm going to have to put a linear expression. So on top of x squared, I actually want to write this, bx plus c. Do you see what I did? So instead of just a constant, I had to add in an x term on top. It's the way it has to work to make this partial fraction all work out perfectly. So if you have an x squared on the bottom, then you have to put the linear bx plus c. What if you had an x cubed? Just asking. What if you had an x cubed on the bottom? Then what would you have to put on top? bx squared plus cx plus d. Do you see what I'm saying? So you'd go 1 degree less on top, but list out the entire polynomial with all the different pieces, all the x's. Okay, but we're going to practice some of those at the end, so we don't need to practice that now, but here we go. So why don't you guys try this? See what you get. See, this is going to be fun, because I'll tell you why it's fun, because how many letters do we have now? Oh, yeah, we do have 4 letters. Okay, how about A, B, and C, which is what we're solving for? We have 3 of them, which means we better get 3 equations. Okay, if you have 3 letters, A, B, and C, you better get 3 equations to solve. Otherwise, you can't solve that. That's like a mathematical fact. So, all right, guys, try this. Add it up, see what you're doing. Plus C, and that's all over x times x squared plus 16. And then we distributed, boom, 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 boom. So on top, I got ax squared plus 16a plus bx squared plus cx. And I'm going to do one more setup here. So that's going to give me a plus b x squared cx 16a.
Well, I got it.
You got something different? And so this guy here is my coefficient on x squared. This guy here is my coefficient on x. This guy here is that. This whole thing here is that. So I get a plus b equals 3, c equals 3, 16a equals 96. So I get 3 relationships. Did you guys get 3 relationships? A plus b is 3, c is 3, and 16a is 96. Oh, shoot. When you divide both sides, what's 96 divided by 16? That's just 6. Okay, so A is 6. C is 3. That makes b negative 3, which means my original integral and your original integral gets rewritten as a over x plus negative 3x plus 3 over x squared plus 16. So the first thing that makes this guy special is that when you set it up, you first have to remember that if you have a nonlinear factor, you have to put something that's linear in top when you do this. Second thing, well, now we got this, now we got something that's a little more difficult. We can integrate this baby, but this one we have to think. So Kaylee, did you do this? No. Did you get stuck here? Did anybody do this? Did we all get stuck? Owen, Olivia, what do you guys think? Olivia, go ahead.
Should you factor out that 3 at the top?
You could very well if you wanted to factor out a 3. Make sure you bring it back in afterwards. Absolutely. That's one way to look at it. You could do that. In fact, after I do my next stage, I might do exactly what you just said. Owen, what are you thinking?
Split it up, so 3x, negative 3x over x squared plus 16 plus 3 over x squared plus 16.
On your FE quiz, you had a bunch of these. Well, not a bunch, but I think more than one, where you have an x squared plus 16 on the bottom. You can break this up with 3x over this, which gives you a u substitution problem, and 3 over this, which either gives you an arctan, or you could use a trigonometric substitution if you want to practice trigonometric substitutions, if you want to practice them. Otherwise, it's a straight up arctangent. I might just do the trig sub just to practice, but yes, we're going to split it up. And that, Olivia, is when I would pull out my 3's. So let me split this up into 3 separate integrals. The first guy is going to be 6 over x. The second one is going to be negative 3x over x squared plus 16. And the third piece is going to be 3 over x squared plus 16. I believe, don't quote me, but I think there's a problem like this on your exam. I'm using exams that the colleagues are giving me, and I'm pretty sure there's a problem like this on your exam. I'm pretty sure. I'm not 100% sure, but I'm pretty sure. Do you see the 3 parts and how we can split them up? So why don't you try it? The first one's a natural log. The second one is a u substitution. And the third one is either you recognize it as an arctangent, and if you don't, try a trig substitution on that one. X equals 4 tan theta. That'll work for you. Okay? If you want. Yep. I'm going to wander. Good morning. I'm so proud of you guys for working so good on a Monday morning. I really am. You guys are working hard. U be x squared plus 16 du equals 2x dx. So that's going to be 1/2 du equals dx. And so this is going to become the integral negative 3 times 1/2 1 over u du, or negative 3/2 1 over u du, or negative 3/2 times the natural log of u. Oh, undo.
You take the tangent of that, you don't actually use the fraction.
So bring him down. So that's going to be 6 times the natural log of absolute x minus 3/2 times the natural log of x squared plus 16 plus. Oh, yes. So far, so good, right? So far, so good. Did I do that right with my coefficient? Did you guys get a 3/4? So let me see how we're doing so far, guys. How are we doing? So the first one, easy peasy, right? That's a natural log. Pull out the 6, and that's 1 over x, and the antiderivative of 1 over x is natural log. The second guy, we split it up, and that gives us a u substitution problem. We let u be x squared. The derivative is a 2x, and so we have that factor of 1/2. So that gives us negative 3/2 natural log of denominator. Okay? So far, so good. So far, we got 2 pieces down. That third piece, we know, is an arctan. It's some kind of arctan, but it's not x squared plus 1. And so often, our brain just doesn't know what to do with it. Now, we can just look up the formula, which I'll do in a minute, but I thought, well, this is an excellent place to practice trig substitutions. Last time we said if you have a pattern a squared plus x squared, you can replace with x equals a tan theta. So that's what I did. Again, we have a formula that's going to give us the same thing, but this is a great practice. If you do your trig substitution, remember, you replace the dx with the derivative, you replace the x with 4 tan theta, giving you x squared, or 16 tan squared. We pulled out the 16, and remember, we used the identity to convert it. Remember last Friday, we took a trig identity, and we converted it down. This guy's really nice because everything cancels and brings me down to the simple integral 3/4 of theta. Theta is the angle whose tangent is x over 4, right? So if I'm looking at what theta is, I'm looking back over here and saying x over 4 is tan theta. So theta is just the inverse tangent of x over 4, right? Theta is just the inverse tangent of x over 4. The arctan, that's on your homework, right? Some of you guys have already done your homework. So what do we got? This is 3/4, so this is giving me 3/4 times the arctan of x over 4. And that's what goes here for this last part. 3/4 times the arctan of x over 4. So that integral have a repeated factor. And by repeated, I mean it's not just one of them, but it's 2 of them. See how it has a power 2 on it? This is the integral of 6x plus 7 over x plus 2 quantity squared. So if it's a repeated factor, the funky thing that we do, I'll show you what we do. We have to list the factor not just once, but we have to list it twice. Just like that. I know, it is weird. But the thing is, if you don't do it this way, and you try to just put x plus 2 on the bottom, everything cancels out on the top. It's the only way that this partial fraction method will work successfully. So you have to count it once as the first power, and then as the second. If it's linear on the bottom, then you just put a constant on top. If it was quadratic on the bottom, then you have to put a quadratic on the top. But I have 2 linear factors here. So on top, I'm going to have an A, and I'm going to have a B. And let me just walk through this with you, because it's a funky setup, but once you get it set up, it's not too bad. What's my common denominator going to be now? Braden. You would think, because the second one's quadratic. But this is this very special case that you just look at your factor. And if your factor, x plus 2, is linear, you're going to put a constant on top. I know, I think the same thing. Keep it written like that, and you just put a constant on top, okay?
If we were to distribute the x plus 2, do we then put x on top or not?
Then you can put the x on top, but then you're going to get a different denominator.
Right.
then you're going to wind up with squares at the end.
Yeah, no, I don't want to do that. I'm just saying, like,
Yeah.
like
You see?
Yeah.
Yeah. But because then you'd have, but that's okay. You could work it out that way.
Oh,
You
I
could. Okay? I kind of showing you the shortcut, quick method here. So this time to get a common denominator, notice you only have to multiply your first equation or your first expression by x plus 2. You don't need to touch the second one, right? Because the second one already has 2 factors of x plus 2 there. So you only need to touch that first one and get ax plus 2a plus b. That's what becomes your numerator for this. Do you see what I'm saying? So when you write, first of all, if you have a repeated factor, you list it twice, but you put 1 degree less. So if it's a linear factor, you put just a constant on top. And then when you come to put it together, you only need to change your first one. So you only need to multiply your first one by x plus 2 because the second one is already x plus 2 times x plus 2. Then you can go through and finish. So you know what a has to be. You know what 2a plus b has to be. Yeah. Got it? So what are you breaking it? So then you're getting it down to that integral. So figure out what a has to be, figure out what b has to be, and then rewrite your initial integral. I like people to kind of discover things as they go. A has to be 6, 2a plus b has to be 7, so 2 times 6 plus b has to equal 7. 12 plus b has to equal 7. B has to be -5. So our integral is just the integral of 6 over x plus 2 plus the integral of -5 over x plus 2 squared. The first guy, easy peasy, natural log of x plus 2. The second one, u sub. Do a u sub on that second one. Do a u substitution. Let u equal x plus 2 on that second one. Du is dx. So what you're really integrating is -5 times 1 over u squared du, which we know is -5u to the -2. Right? U sub on that second one. What is that giving me? Add 1. -5 over -1 u to the -1 plus c. So 6 times the natural log of x plus 2 plus 5. U to the -1 is x plus 2 to the -1 plus c. Or if you like, some people like to rewrite that as simply 5 over x plus 2 plus c.